Welcome back everyone. Let's make a revision about the acceleration at first. If you remember about the acceleration graph, we said that if we are talking about the acceleration graph, we should to have here velocity, okay? In this line we can make a delta V, and in this place we have that the time, okay, in this part. That is the velocity graph. But in this question, he asked about the object still. It means at rest. It means not move. Of course, number B, it will be the right answer. Because here, in this case, now this object not move. Suppose that this is the 2 meters. After 1 second, still in 2 meters. After 2 seconds, still in 2 meters. After 3 seconds, still in 2 meters. Now, with the position with time, it refers to still in place. Okay, guys, just a minute. I'm so sorry. Sorry, my friends, I'm back again. Now, this for this question. Yeah, what about, where is my pen? Just a minute. Yes, okay. Now, what about the acceleration unit? Of course, guys, we said that before. A equals delta V divided by delta T. So, delta V measured by meter per second, and the time measured by second. Now, meter per second squared. Don't forget these. This is very clear and very easy. Now that is the SI unit for acceleration. Of course, guys, when the object speed up or slowing down, both of them make acceleration. But most of time, when we have a negative acceleration, it means the object slowing down if the object move in this direction. If the object move in this direction and start to slow down, in this case, the acceleration will become negative. And today, inshallah, we will talk about the sign of the acceleration. I hope you understand this part. Let's move for the new lesson for today. Be careful when you speak about position and time, that is velocity. That is velocity. But in other hand, the acceleration, it will be the relationship between velocity and time. Don't confuse for that. Okay, now let's explain the acceleration graph. How can we understand the movement of the object from the graph? Suppose that we have here, okay, suppose that, guys, we have a car, and this car move in this direction, very old car, like that. Okay, and this car move in this direction and start from 0. After 1 second, the speed, it will become 20. After 3 seconds, the speed increase to become 30, 40, and become 120 kilometer per hour. Okay, maybe after 5 minutes or like that. Anyways, now when this one reach 120 kilometer per hour, still like that for maybe for 6 minutes. Okay, now in first 3 minutes reach 120 kilometer per hour. After that, still 100 kilometer per hour for more 6 minutes. Okay, and after that, this car want to stop. Now slow down, 120, 100, 80, 60, 40, 20, 0. At rest, become at rest at the end. Slow down. Now look over here for the graph. Now this car started from 0 like that. Here started from 0, and now increase constant speed. Now increase in constant speed. Okay, and I'm sorry. Now increase constantly. Now increase constantly. Now we have speed here. We have a change in speed in this case. But here in the middle, the car nothing change in speed. The speed is still 120 kilometer per hour. What does it mean? It means no acceleration. No acceleration in this case. Why? Because we do not have any change in speed. We do not have any change in the velocity. We said that at the beginning. If you look over for the definition of the acceleration, acceleration is a change in velocity. If we do not have a change in velocity, we do not have acceleration. It's easy. Okay? A change in velocity, acceleration. No change in velocity, no acceleration. Clear, guys? Now, at the end here, this car start to slow down and the acceleration become negative. That is the graph of the acceleration, and that is how can you understand the movement of the object just from the graph. Okay, so sometimes I will give you lines like that, x and y, here delta v, here delta t. Okay, when I draw like that, in this case I will give you choices, and I want somebody to answer the question. The acceleration here equals what? Acceleration here equals what?
Zero.
So just a minute, please don't answer. Don't answer, please. I don't give you permission to answer, my dear friend. Okay, now suppose that here the velocity is 120, okay, and the line it will be look like that. Now the acceleration, how much? It will become 120, become 0, or become 30 kilometer per hour. You can open your microphone. When the object is speeding up or slowing down or change direction, all of them are acceleration. But of course we have different sign, okay, but anyways all of them are acceleration. But here in speeding up, we can say that in English we can say he accelerate, the boy accelerate. It means speeding up. But in this case we can't say that he accelerate, slowing down and accelerate. No, specifically if we are speaking in English, we can't say that this boy slowing down and accelerate. Wrong. Okay, he has acceleration but not accelerate. Anyways, speeding up, slowing down, change direction, all of them are making acceleration. Great. Let's move for the sign of the acceleration. Look over, my dear friends, I don't want you to confuse. Let's take it very simple, very easy. If the object slowing down, the sign of the velocity will be opposite of the acceleration. If this one positive, this one negative. If this one negative, this one positive. The opposite. And I will explain right now. But if the object is speeding up, they have the same sign. Positive, positive, negative, negative. Now let's explain. This object to move in this direction, you know that we have a positive direction and a negative direction. This is the positive direction east and negative direction west. Okay, now this guy moved for the positive direction, so the velocity will be positive, but he's slowing down, and we said that when the object slowing down, the acceleration will be negative. So the velocity in this case positive and acceleration negative. If you look over here, now this guy moved for the opposite direction, moved to negative. And when he makes slowing down, the acceleration will be in the opposite direction, be positive, like that. Very simple, very easy. Okay, and speaking up, I think that's clear. The constant acceleration equations. We have 4 equations about the acceleration, constant acceleration. Of course, guys, we have a lot of steps to understand how we get all of these equations. Now we have 4 equations. You should to memorize them all. That is so important. But of course, I don't want you to write many times in your paper. Of course, no. When we answer a lot of problems, you will understand and memorize them. Don't worry. Okay? But you should to practice a lot, as I tell you every minute. Anyways, now here all of these equations, we have steps to get it. If you look over for the first one, I just give you very little. You don't need to understand that, but I will explain that quickly for you to know from where we get this equation. From where? Now, V average. What's the meaning of average? Average, it means the total divided by number. Total divided by number. Now suppose that we have degrees for all class, 1000 degrees for 20 students in class. That's all degrees. Now if I wanted to get the average for the degrees of all class or marks for all class, I will divide all of them divided by the numbers of them. So now we have VI plus VF divided by 2. There are 2 here. 2. Okay? Now, it will be like that. If we make V average delta x delta t, it will be at the end like that. Anyways, I don't want you to confuse. Don't care about that. Now let's move for this. Let's move for this. Now you should to memorize them all. You should to memorize them all. And as I tell you, don't worry, you will answer a lot of problems and you will memorize all of them automatically. Now, yes, question? Let's make revision for these some symbols we have here. What is the delta x? What is the vi? What is the vf? What is the delta t? What is the a? What is all of this here? Now, I want someone, please, guys. Okay, now that is the some symbols meaning for all. And here, let's give you some notes about how can you understand from the problem what he need or what he gave you. When he said that the object started from rest, now he gave you vi equals 0. And when he said that he ends with rest or become rest, okay, now at the end the object stop moving. Now vf0, be careful, please. These are very important points, okay, to understand how can you answer the problem. Okay, what else? Okay, maybe we can get out another notes from the problems. Now let's move for problem to understand how can we deal with the problem. Okay,
negative acceleration.
Now we have negative acceleration. Okay, you should write all of this information. We have negative acceleration. Okay, complete.
Using its parachute and braking system.
Yes.
And comes to the rest.
Yeah, come to rest. It means that vf0. Yes, complete.
Find the distance that the car travels during braking.
Yeah, during brake. And when if in 5.5 seconds, it means delta t equals 5.5 seconds. Okay, now he wants that the distance. Of course, guys, he don't ask about displacement. We have difference. Anyways, now you should to memorize all the equations. Now, if you have the all the information in this problem, you can write it here: vi 42 meter per second, and vf equals 0, and delta t equals 5.5 seconds. He wants that delta x. Okay, quickly we'll back again for for these equations. You can see that which equation it will be better to use it. First one, we have vi, we have vf, we have delta t. Okay, now we write it. Now we write the equation: delta x half f plus vi delta t. Okay, now like that. Now we have all things here: half vf 0, vi 42, delta t 5.5. By calculator, I don't know what the number it will be. I want someone to make it, please. Okay, Dimitri, just it. Any questions, guys? I have finished. Any questions? Thanks a lot for listening, guys. I hope you understand. I hope you enjoy. If you have any question, you can ask me on WhatsApp at any time. Thanks a lot. See you next time. Assalamu alaikum wa rahmatullahi wa barakatuh.